Okay, see, we are discussing now maneuvering, which I mentioned is essentially motions in the horizontal plane as far as shape is concerned. Okay, now I will quickly draw this definition diagram that I had drawn last time. That is essentially necessary just in order to we have this let me just quickly draw that. Okay, what this is just quickly a recap of what we have done. See, what is happening is, remember, we are discussing now the subject of a ship maneuvering in a horizontal plane, and I have mentioned that in last class during introduction is that the way it will behave depends purely on the hydrodynamic forces that gets created on the body because of the flow past it, because of the fact that it is not moving with zero angle of attack. See here, this is the trace, this blue line is the trace of its center of gravity, some point we are taking as CG, the trace of that, and the orientation is of course given by this beta and psi angle. Now, we need to know is to find out this trace along with the orientation. So, we have, as we mentioned, defined an inertial system with perhaps an origin at O, which is inertially fixed, earth fixed, O x 0 y 0. We have a body fixed system called G x y. The body has an velocity vector v, which is somewhere in this side. Therefore, it is going with an angle of attack or drift angle beta, because it is moving this side, but its body, like orientation is here. So, flow comes this side, flow gives forces, and these forces must be equated to or used in an equation of motion. Okay. Now, what we are going to do, see that let us say this distance is my x, no, this is y, sorry, this is y, x 0 g, and this is y 0 g. Okay. So, according, and let me also define certain quantities. The forces on the hull along this direction, that is along the direction, inertial direction, let me call it x 0 and y 0. That means x 0 y 0 are forces on ship along x 0 y 0 direction or in earth inertial system. Similarly, x and y are the forces along the body system, which is defined with origin at G and x axis here, y axis here. Okay. This is the body system. That means G x y is body system. Or rather, let me go back to this. So, I have O x 0 y 0 is inertial, and in that system x 0 y 0 are forces, x 0 g dot y 0 g dot are velocities, acceleration. Okay. Now, g x y is body fixed system. I define x and y is forces, u and v are velocities, u dot v dot are. See here, once again I will tell you, inertial systems are all 0, x 0 y 0, therefore capital X 0 capital Y 0 are forces along this direction. N of course is the moment, which of course remains same if I call this to be moment n. N will remain same because in this diagram the direction z, body fixed direction z is downward to the paper, that is if you go clockwise in a right handed system x to y downward, which is same as far as inertial system is concerned as far as body system is concerned. So, as far as moment is concerned it is same, it will be n, whether n 0 and n are same. Okay. Now, what we have written is here is that if I take inertial system, my forces is x 0 y 0, x 0 y 0, my velocities are x 0 dot dot y 0 dot dot along those direction here, and acceleration is next derivative. But if I take a body system, it is my forces x and y, x and y, velocities u and v, and acceleration is the dot. The question is that I have to write or develop an equation of motion, Newton's equation of motion, which is suitable for me to study, and ultimately I have to write in the body frame. Now, let us look how we can do that. See, the inertial frame of reference, my Newton's equation of motions, which will apply of course in inertial frame. Why not in body frame is because body frame is rotating. Remember, the body frame is rotating, it is not a fixed frame. So, we have to transfer that using some mechanism. So, I have x 0 equal to mass into x 0 d dot dot, y 0 equal to mass into y 0 g dot dot, and n of course I can call it I, let me call it I z dot psi dot dot. Going back to that, see here, force is mass into acceleration, okay, standard. Or if I have to look at that, this side force is mass into this side acceleration, is inertial frame of reference. Now, the point is that I need to transform that both this side, I want to rewrite this in terms of x y, and I want to rewrite this in terms of u v. This equation, right hand side and left hand side, x 0 y 0, x o g y o g, that is body inertial reference, but I want to transform that and write them in terms of x and y, and in terms of this side u and v. Why is because remember that what is this forces, there is a shape here, the red one, I want to find the force acting on that because of its motion, and if you are sitting on the shape, you are much better off to try to determine the forces along its x axis and along its y axis, because along its x axis is a resistance force, along its y axis is a sway force. So, if I were to do along this x 0 axis, it can be arbitrary depending on the orientation. Tomorrow the ship might be oriented this way, then my x 0 force becomes actually sway force, then next instant it is this way, my x 0 force becomes my surge force. So, it becomes difficult to define, that is why I need to transform them to this x and y axis. So, that is the thing that we will be doing now slowly, that is transforming this to that axis. How do I do that? It goes actually using this transformation matrix. Now, I will just tell about a transformation. Supposing I take two coordinate system. These are the orientation between the two is this. One is my x 0 y 0 and one is my x y. This angle is basically my psi or theta, whatever you call. Let me call it theta right now. We can make theta as psi later on. Now, you see this, everybody knows that now any vector defined with respect to this, that is in this coordinate system, and another one is defined with respect to same one when I define with respect to the coordinate transformation. That is essentially what I am saying is that by coordinate transformation we know that x and y in fact, if you look at that, you will find out essentially x equal to x 0 cos theta plus y 0 sin theta and y equal to minus x 0. This is standard. Like if you basically, I don't have to go through all this stuff. If you this is my x. So this is actually this x 0 cos theta plus y 0 sin theta, etc., etc. This is a standard coordinate transformation, that is transforming a quantity in coordinate system x 0 y 0 to x y or x y to x 0 y 0. This is x y to x 0 y 0, getting x y from x 0 y 0, and if you want to do the reverse, you simply have R inverse, because R can be inverted and R inverse is R transpose, that we all know. That means if I were to do the other way around, that means if I want to do x 0 y 0, this becomes equal to R inverse, which becomes, and this becomes, I will just take my privilege of using this thing, becomes same as RT. So that RT, which is equal to R inverse, this is actually simply the change. Cos theta comes here, minus sin theta comes here, and sin theta comes here, cos theta comes here. So this allows me to change one to other. So then what happened? Now we are now in a position to write this way. You see here. Now x, force x and force y. X, remember what is x? X is the force along the body axis. So x and y I can write in terms of this thing. I can straight away write actually here x 0 cos theta plus y 0. Remember here x 0 y 0 are, well, it applies to any vector, right. So in this case I am applying the force vector, because capital X is the force. See, it applies to any vector. What it means is that if I define a vector in a coordinate system 1, how do I get the components in the coordinate system 2? Just by a simple transformation, that is all it says. So x force in coordinate system body, that is given by capital X, is basically capital X 0 cos theta plus y 0 sin theta, because this force vector essentially here what is happening is, remember, body force vector. I have a body force vector here, some body force vector, just like this. Instead of that, instead I just call it body force vector. So this vector has components either x 0 y 0 or x y, depending on how you are defining them. So they basically are related to each other. If you call x 0 y 0 or x 0 y 0 or x y, they are related by these relations. So that is what we are writing. Y 0 becomes here, y becomes here, y 0 cos y, okay. In fact, we can write it that basically y 0 cos theta minus x 0 sin theta, Actually, we should write minus x 0 sin theta plus y 0 cos theta, same thing. Okay. Now, similarly, now the other way around, u and this thing, u v with x 0. Now, u with respect to x 0 system, which is actually x 0 dot g, I will write that is equal to x dot o g, and v in with respect to this, well, this x 0, basically x 0 system, inertial system, which is equivalent to y 0 dot g. Now, this, remember here we are doing reverse, the quantity in O we are writing in terms of u and v, which is the same thing, of course you can write either way. So, this will simply become u cos theta minus v sin theta, and this will become u sin theta plus v cos theta. Okay. This becomes u sin theta plus v cos theta. I mean, it is opposite, no? See here, this u v u sin theta plus v cos theta, opposite here. No, this R T coming, remember. See here, what I change is dot to this to this. Previous one in the force, what I did is this to this. That's why it was R and this is R T. The same. It is very trivial. Really, we need not go through all that so much in detail. Now I will just rewrite that because we need to do this thing. So we enter the heading x equal to x 0. Now let me put now straightway instead of theta psi, because actually ultimately what is happening, theta is my, remember this theta was a general coordinate transformation, but in our case this theta, as you know from definition of this diagram, psi, because psi was the angle between this horizontal line with respect to the heading, not beta. Remember psi, beta is the direction of velocity vector with x axis, but direction of x 0 axis with x axis is psi, heading angle. So I end up getting this plus, now that there is a reason that will be, I am writing this for, because it comes to, this is one, and now actually these pains are all, this double dot, the problem will come. And now comes the question of, this is plus, right, absolutely. Now comes the question of acceleration, x double dot o g. It is basically what? Remember now, this is d by dt of that. Now what is this? This is C d by dt of that into this, etc. So this is going to be u dot cos psi, okay, first term, plus d by dt of cos psi into u. Actually I could write u here. See, rather let me write it down separately, okay. This is basically, see here, cos psi du by dt plus u d by dt of cos psi, right. And similarly this side is become sin psi dv by dt minus v into d by dt of sin psi. Now this C is u dot cos psi. Now this term, now d by dt of cos psi is what? D by d psi of cos psi into d psi by dt. So this is u d by d psi of cos psi into d psi by dt Okay, like that we can write this becomes V dot into sin psi minus V into d by dt sorry d psi of sin psi into d psi by dt. So, if you just you can work it out and find it out, this will turn out to be u dot cos psi. I will write next line again, write that V dot, that is coming from here, this one, see here, this is psi dot, remember this term is psi dot, this term is psi dot. So, this is psi dot d by d psi of cos psi is how much? Minus sin psi. So, it is minus u psi dot sin psi. So, if you basically, and this term is what? D by dt of sin psi, this becomes basically cos. Okay. So, if you do that, this will become minus of, maybe I should go to the next page, u cos psi plus v psi, no sorry u sin psi, actually let me write it down next page, just following it up, otherwise it is becoming confusing here, just keep that here and do it. Okay. See here, I will just write here, this one, this term is u minus u sin psi into psi dot, because you know d by d psi of cos psi is minus sin psi, or rather let me write it again, otherwise it is becoming confusing. See u dot, this is, I will just repeat this line, here, see this is minus sin psi u, right, this is minus v cos, these two terms minus u okay, this is what we have got. So, similarly, exactly similarly, if you did the other one y 0 g dot dot, I will not go through this full thing, but you will end up getting here u dot sin psi plus v dot cos psi plus okay. So, you have got this x 0 and y 0 expression, right. Now, if I put this x 0 y 0 expression in that equation of motion, that first that we wrote, that is mx, where is that expression of the one that we wrote, one second, no, it's okay. Now, Newton's equation of motion, see this equation x 0 equal to m x g dot dot. So, if I put that here, this, because what I have done is, see, first step I have now represent that in terms of u v. So, if I write that, now this whatever I have got x o g and y o g, if I write that I end up getting this thing, I just write that straightforward, I end up getting x 0 equal to, see, m into this thing, now m into x o g dot, that m into this part, that is m u dot cos psi minus m v dot sin psi sim dot u and y 0, I end up getting well. Or actually we can write it this way. So, we have got this expression, right. So, this straightforward expression here. Now, next step is actually I must rewrite this in terms of x y. Okay. Then see what happens if I now change this in terms of x y, then I have a relation that will be x equal to function of u v, y equal to function of u v. That is what exactly we are trying to do. So, if you are going to do that, now you see x 0, we already wrote that part, of course. Where is it? Or rather we will rewrite it, because here we are trying to do the other way around. See x 0 is x see this is the transformation, right. Now, what we are doing, this is equal to, remember this is equal to this x 0 is equal to this side, this y 0 equal to this side. See this x 0 y 0 are basically given by these two, okay, and this side of course is the other side. So, when we write it up, we end up getting something like this. I just want to write this, because you will see this. See x cos psi minus y, this becomes equal to m u dot psi minus m psi dot v, there is a v there, minus m v dot psi minus m psi dot u sin. So, this we can also write is that m u dot minus m v psi dot cos psi minus m v dot plus m u psi dot sin psi. You know, it is just manipulation of that. The other part is x sin psi plus y this is very interesting, you know. Now, I will rewrite this, you will find out that, see here why we do that, we did not have to solve it. See this part same as this part, this is same as this, okay. So, if you see x cos psi minus y sin is something cos psi minus something sin psi, x sin psi plus y cos psi, same thing into sin psi plus same thing cos psi. I do not have to solve it, you could have solved it, or you immediately know x equal to this, y equal to this, right. In other words, if I were to write it, this was the purpose of going through this. Many other ways you can arrive at the same result, many other ways, but this, the interesting point here is that all that we have done is something like that. See here we found out this, you can say cos psi minus sin psi and sin psi, whichever way you can write actually, cos psi this is what I wrote, this one, this side, cos psi minus sin psi cos psi into xy, that is what will, you know, and this side I will write the same way, it is also cos psi minus sin psi. I will just show it to you. Here it is, you end up getting m u dot minus m v psi dot and m v dot plus m u psi dot. You see here cos psi sin psi cos psi, what I wrote here, and this term the same thing. So, if you root that, immediately you know x equal to this, y equal to this. See, so that means what I get is, I will just write it down, x equal to m u dot minus v psi dot, y equal to m v dot plus u psi dot. Of course, if I were to write n becomes I z So, this becomes my equation of motion in the rotating system. Of course, you see, I will just in a minute tell you, we have gone through this coordinate transformation etc., etc., but you know, this is a very standard procedure. It is not known for maybe 100 years now, based on any rigid body kinematics. If you actually have studied basic mechanics, you would have seen in any statics and dynamics book, the equation of motions are written, can be written in a moving frame of reference. This is actually moving as well as rotating frame of reference. All I consider is only x, y, but I will show you the full form if you consider x, y, z as well as all rotations. The point is that it looks like that. What do you find out? Force in that direction is mass into acceleration and direction, but there is an extra part coming. That is what is called lateral acceleration, mv psi dot or mvr. It is like your like Coriolis force, rotating frame of reference, similar to that. This is the important point to recognize. Psi dot, if psi dot was 0, of course force is mass into acceleration, they translate to each other. Y is same, n no question comes in. Some people will write psi dot is as r, rotational velocity. R psi dot is rotational velocity here. So, you find x is mass into acceleration and an additional term, additional force come mv psi dot, mvr. mvr is m omega square by r, because r is v by the way you talk, if r or omega, the way you talk, mv square by r is the centrifugal force. This is nothing but mv square by r. This is the same thing. So, basically what is happening, you are having these additional forces arising because of the fact that it is rotating. In other words, if I was to look at this body, at the instant it is here, it is also rotating. As it rotates here, additional force come in the direction x and y, arising because of the rotation. That is the point I was trying to now tell. Now, of course, having said that, we will come to this G part later on, but let me just tell you, just without anything else, see what happens. This was very simple, we have done it, but if you were to take a general body, submerged body, you call it x0, you call it y0, we call it z0. We have a point here, this point may be point O, and I have an axis system of x, y, z, and I call the forces x, y, z, k, m and n, that is x, y, z, k, m, n, the three forces along the body x, y, z axis, 3 rotation about this x, y, z axis. If you were to define that, if you were to go through the same equation of motion, mass into acceleration is force, you end up getting And also if you were to take a general point O, which is not a center of gravity necessarily, some point O which has a coordinate of with respect to g, x, g, y, z, z, etc., means O is located at a point from which the center of gravity is x, g, y, g, z, z, you end up getting the expressions which I want to just show it to you, which is well known, which applies to any three-dimensional body like a spacecraft, missile, torpedoes, submarines, aircraft, anything. They are well known. So, it turns out to be an equation like, because we should probably see that u dot. Now, I will also tell you one thing is that u, v, w are linear motion and p, q, r, they are called the rotational velocities. In our case, remember, psi dot is r, but it is not necessarily true for a general body, because here the orientation is not same, z axis may not be same. So, there is again different transformation there, but anyhow p, q, r are the velocities along its own direction, that is velocity about this is p, pitch velocity is q, yaw velocity is about its own axis is, remember, yaw velocity about its own axis. If the body was like that, velocity about this axis is what we are called r. So, then what happened? It becomes v r x, g, y, g, z, z are the coordinate of point O, g with respect to O, that is my O is here, g may be here. So, x, g, y, g, z, z are this coordinate of this point as measured. Why I want to show you is that, see that we are dealing with a extremely simplified form of this equation, although we know the entire part. This x force, let me write it from little bit this side. I have a reason for writing this, while because there are forces originating from different y g is the 3 here, but then I x x p dot let me just write it, because I have a reason for writing this. No, sorry, I x y plus m y g w dot minus plus v p this is roll Yes, let me complete this two part also quickly. Rp minus P dot, because what I want to show you is that from there, first of all the origin of the terms, second of all how it can be reduced to our shift form, the one that we have used, and of course we talk what we do with all this. Yeah, we are just almost there. I y z plus m. There is a nice cyclicity in this equation. That is another thing which I want to write it the full form, so that if you write one, you can get all of them without making a mistake. Last one, z z r square plus I y y minus I x x p q minus q dot r p I z y plus I x y plus r q minus p dot I z x plus m x g v dot minus I am just completed v r. See why I wrote all, I will tell you, you see all whole lot of this expression, what we do with all that, etc. The point is that in a 3D case, you see what is happening. Look at this, we will look at this y and this equation more. M v dot we had, M u r we had, but when you have a 3 dimension, then you also have this w p, another one, because it is on the 3 dimension. The vertical, remember w is heap force, p is roll. Then because y g, z g and x g are not necessarily 0, there are additional force coming, remember, for rotation. Remember, see the body is something like here, but rotating about this point, because I am defining here, but I am defining the forces about this axis, but rotation is about this point. So, as it does, there is an additional component that comes p square plus q square into those distances, that is kind of a inertia force that comes it, p square, the rotation square into the distance. So, here this is okay. So, like, and on the additional terms also come like that, y g, p q r, etc. All these are coming because of this fact that there is a rotation at a different point where you are taking the force. You are taking a force here, but rotating about this point. So, as you rotate here, there is a component of force that comes. If you look at this rotational component, you have p that. Now, these terms are coming, z z y r q r is again because of the fact this will of course will come always from the expression. Now, these are coming x z, y z, etc. The reason is because you are defining the coordinate at O, not at G. Had it been at G, then I of course I will have this only the principal moment of inertia, but because I am not at G, I am at O, I have got this additional term coming. Similar way this comes. The other thing I want to tell you, cyclicity. If you have written this one, you will find the first term u v w p q r, u v w p q r, v w u. If you see, if you make a cycle u v w, if you start from there, like it will always follow. V means w, v w u, r p q. All these terms follow. If you actually write a, like a circle, like what I should say, like make a circle like u v w, and if you do another one p q r, you will see that all these terms, if you start from here, next one will be this one. Like if I have, say here, the rotation q, the first term is q into r, the next will be r into p, and next will be p into q. So, if you write one, you can just see, if you write in a line, you just have to see the first one rotation. It will be always in this sequence. If the first one is this, next line will be this, next one will be this. Even if in i's, I x z x y y z x, same way x y z, if you see that x y z y z x z x y, that is the sequence. So, there is a very nice cyclicity, although it looks big, it really, you do not make much of error in that. Now, what we had in our equation? Only the two. I had this one and I had this one. Actually, I had only this this 3, I can say, because if I take x. Now, what did we get? You see, if I look at that, I got here m u dot and v psi dot. I have got this term and I have got this term. This is not there because I hat is 0. I had taken it, remember, I had expressed that in 0. Now, supposing I do not do that, now this I will come to that. Supposing I do not do that, what will happen to this? Then I will come to that in a minute. Okay. So, I have got this term, you can see from here straightforward, and in here I have got obviously this v term here. I do not have this, I have this term, and I none of have this term. Okay. And if I look at that, none of them is there, only this term there, because all are 0. I do not have p q and all that. Now, here comes one modification. See, quite often, look at this expression. Quite often we do not want, I will let me just draw another diagram. I have this shape here, G is here, but I may not want to define that to be the origin of the body coordinate system. Why? Because remember, I have to measure the forces at some point of time, all these x, y, z forces. Quite often it may be convenient to define the forces with respect to a point which is fixed on the geometry, not on center of gravity. Remember, if I take a point O, which is somewhere like say LBP midship, that is a geometric fixed point, but center of gravity point depends on the kind of loading. Suppose I take a particular hull, I would have midship at a given location, but its LCG can be anywhere depending on the loading condition. Okay. Now, the fluid forces that comes around it, that is on the right hand side, on what they will depend? They will depend only on the external geometry, right. See, the fluid forces that arises because the flow is going past it, they are depending on the geometry of this hull. Does not matter where the G is located. G can be located arbitrarily depending on the loading condition. So, since at some point of time I have to be worried about the fluid forces, it's sometimes convenient to find out the decide the coordinate system at a geometrically fixed point, because if I were to have geometrically fixed point here, I will be able to find out. See, for example, I rotate it about this line, I have this ship, and then I want to find out the flow past it. Okay. So, as a result, quite often it is very common to apply these equations with O, with a center of, with the origin taken at a point which is not a center of gravity. However, it will not be along this line, because remember, ship is symmetric, port starboard. So, normally you will take an O which is along the center line. Therefore, you are likely to have a non-zero xg, but yg will be 0. So, if that is the case, then I end up getting an additional term minus xg into r square here, this term that I will write it down here, minus xg into r square. That means, I will end up getting here, if I were to do another term here, see, minus xg, well, m minus m xg into r square, or if I were to put it inside, it will be minus mx. That means, what I will end up getting if I were to write here, m u dot minus v psi dot minus m xg r square, right. And in this I will end up getting an additional term which is going to be here minus yg r square, m v dot plus u r minus yg I square. You see, m v dot plus u psi dot minus m xg r square, that is m xg r square comes in. So, I am not deriving this equation any further, but depending on that we may use this or we may use this depending on where you are taking the origin. This will be more general because here you are taking the origin actually. In fact, there is one more point on this, there may be also some more complication may come, because what will happen, I do not have P, I do not have Q, but I have R only. So, let us see that there is any R term come M x g, yeah, here an additional term will come, remember M x g U R. M x g V dot plus U R, this term will come because V is also not 0. So, you will have I z z R dot plus M x g V dot plus U R, this term will come extra. Okay. So, what I am trying to say that it is very possible for me to modify these equations, we will be looking at that later on. Now, what would happen is that in our case we really will not look at this much because it is an independent coordinate down. We will see that later on. We will be able to use these equations, this tree set. Now, what happened? Okay, I have this equation. So, what? The next question. This equation has nothing hydrodynamics about it. It simply says mass into acceleration is force. That is all. It does not tell what is the force, how much is the force going to be more, less, etc., etc. So, obviously, our next job would be, most important job would be to look at the hydrodynamics. Where is the hydrodynamics? Purely in x, y and n. It is this x, y and n which are the representation of the fluid forces acting on the hull. What we said here is that if I have a force x, then x must be equal to m u dot minus v psi dot, where u dot u v and psi, u dot v dot psi dot are the so called velocities, displacement, etc. Right. So, mass into acceleration equal to force is what we are trying to tell here. So, now the next job, which is what we will be doing, the most crucial part of the job, is to now find out separately how I represent x, y, z. Remember this equation, and as I just mentioned, this equation has nothing to do with hydrodynamics, etc. It is only to do with rigid body kinematics and dynamics. Any mechanics book you also would have done in your second year of mechanics courses, that your truck is going with the crane there, the crane rotating and some weight is coming down. We used to do in our student days, therefore find out some force and acceleration. You are standing on a lift, you are going, so you throw a ball, at what rate it will come down. Essentially you are looking at the rigid body kinematics and writing equation of motion or representing forces in a moving frame of reference. The frame can be linearly moving as well as rotating, etc., etc. That is all. So, this only represent, this side only represent that. This side only tells me if I were to express forces in a moving frame of reference, what are the additional forces come because of the fact that the frame of reference is moving. Nothing to do with the right hand side, which is my actual forces. So, next class as we continue, we are going to look at this side, because this is what decides the behavior. Okay, so, with that we will end today's class, but we will look at this and then we will see how we go on study. All this equation ultimately has to be applied to me to study how the shape would behave if I were to turn or if I were to make a zigzag. Okay, with that I will end it today.